And I can see the first few people who have actually mentioned they're joining from Portugal, from the Netherlands, I believe. Correct me if I'm wrong. On the UAE, from Lebanon. So we have a very international audience today of people who are willing to, learn about optimizing OPEX. So, right. So without further ado, please, Ruben, over to you.
Thank you for the introduction and welcome everybody, of course. This is Ruben Martin and I'm sharing here from London today. We want to just share a few details on how the operations are currently trending, what we are seeing for the future, and definitely what insight can you gain for your EPC or new projects, or if we are acquiring a portfolio and planning a new strategy, what can you think of in terms of this aspect? Then you can all see already my screen, just to confirm. Everything is fine? Good.
Yes, everything is good.
Perfect. So let's go on. Please share your questions and answers. Share your questions in the bottom, and we will be trying to grab as many as possible and answer them in due time. Well, just a brief introduction about us. We are a global company. We have been in the market for 18 years already, starting in Germany with a very small team in the very early stages of solar in the country. And then we have now developed projects in the 4 continents, basically, and expanding. We are now, from the picture that you can see, we're expanding now to Spain, Portugal, Canada, and emerging markets in general. And we are part of the RWE large utility scale company in Germany. We are part of their renewables energies. And within the network, we have quite a lot of expertise in different technologies, different mounting structures, construction methodologies, and of course, different operation methods that we can see. Part of our company, or one of the branches that we have, one of our sister companies is called Patcon. Is a company that is experienced as well in monitoring, and we gain a lot of insight and valuable documentation, not only for new projects, but also for existing projects, in terms of what data is valuable, what data can be used for improvement of the services, for improvement of the understanding of the system, and to prevent and predict much more the operation and the expectations of our solar farms. In terms of what we can see and how we see currently the market going, of course, now PV is quite a mature market, quite a mature technology. We know much more and we have acquired much more intelligence on how to operate and what we expect of solar that in these past 10, 12 years of so much installation, so many installations in different markets in Europe, in America, even in Africa and Asia. And the trend and what we can look for, it's basically condensed in these 8 major topics. Most of it is making it much more digital, having a reporting tools that are related to tablets or phones or things that are easy to carry, easy to integrate, giving a visibility also to the stakeholders or asset owners, asset managers, whoever is in charge or responsible for it. It gives much more validity to the documentation, and we're going to see a bit on that. We're seeing a trend of larger portfolios, not only single larger projects, but also clusters of projects of smaller size, but going together. And this is something that is happening in different countries. We are experiencing and we can benefit a lot from intelligence and knowledge across sectors. So we are not only having now all the information that we have from the solar industry, but we are merging the knowledge as well with industries like wind, thermal, or biomass, and so on. And the technologies that are used in the different markets, like, for example, using refractometers or technologies that are used in the automotive market or in the automotive industry, to improve the way that we analyze the information that we get and to improve the way that also we perform our maintenance. There is a lot of competitiveness. There is a lot of expertise now in the market. People who have been moving from countries to countries or from companies to companies, and that have been partaking in different roles and areas of the market. They have a lot of expertise now, and there is a lot of value now added into the O&M business. Cybersecurity is one of the hot topics. A drone service, how to improve the automatization of the services and of the audits of our solar projects. And instead of spending man hours on site, how to improve it with automated services, grid integration, implementations of different technologies, and the communication with the distributed network operators or the grid companies in the different countries, and future trends like 3D printing, integrating the solutions that we can see now, for example, in automotive industries or car racing or some sports, for example, implementing those improvements also, why not, to our operations and reduce the costs of creating bespoke tools and parts for replacements in the future. In terms of what we can do up to now with drones and with automated systems, we are performing, and it's part of routine maintenance already, thermal inspections. We can perform electroluminescence tests, dark IV tests, topographic surveys to assess the conditions after and the conditions before, and surveillance of the solar farms with drones. Most of it, this is not only for O&M, it can be already implemented through the construction period to keep a much more accurate track on how the project is developing and planning ahead before the operational phase of the project happens, so that we can have a deeper insight on how the system is looking like at construction phase, and the handover to the O&M operator can be much smoother. The more information we have is always the better. And because of that, having all this information collected along the construction phase and even the pre-construction phase, having a record and a track along the time gives us so much value that cannot be missed, definitely. One of the things that we, for example, see and have quite a big relation to the construction phase and to the design phase is the PID degradation. This potential induced degradation is very much related to the technologies of the components that are used, to the environmental conditions of the system, and of the area, and to the construction, the quality of the construction in itself. It is very important because afterwards, during operation, there is a lot of losses involved in PID degradation. And the sooner we tackle this problem, the better. We will see one of the slides later. Even in construction phase, there are systems to be integrated that can reduce the PID degradation, that can be implemented with a lower CapEx cost than if it is afterwards implemented in an already operating system, and that will save the stakeholders money in terms of added revenue from reducing losses. This is one system that Patcon has already developed. It's a different system to many of the manufacturers. It's bespoke and it's a proprietary technology. It can be both implemented in existing plants, but also in new PV plants that are being designed and constructed. The main interest of this is protecting the modules from PID degradation. If they are thin film, protecting them from irreversible degradation. If they are polycrystalline, protecting them from losing energy. Of course, this can be recovered, but if we can prevent it from happening from the beginning, it's gonna be a win-win situation for the stakeholders and for the owners, definitely. Another of the topics that we can focus on is about data, not only what is done in the field, but also about the data that we have and how it can improve and reduce the amount of time that we spend in the field, and how we analyze the information to understand the system better and be comfortable that the system is operating in the best conditions, or if not, what can be done and where to look at if we need to solve something. Here we can see basically 4 different areas of the operations and maintenance activities. There is an area that is the optimization and performance of the system. We can have much more predictive analysis if we have sensors in the field that are adequate, that are of good quality, a monitoring system that is grabbing as much detail as possible. For example, with our PATCON systems, we have up to 1 second data, which enables us to zoom in and see the wavelengths and the waves of the signals so that we can understand more realistically what's happening and predict reasons why the inverter, for example, is not operating, or why the transformer A is having more losses than transformer B, and then trying to tackle the problem from the office perspective or from a more engineering perspective rather than having a bit of ambiguity on what's the issue. There is also a second part that is preventive maintenance and physical regular maintenance that have to happen on site. There is also some part of this that is involved in the EPC and construction period. For example, issues like drainage or landscaping. We are seeing so many problems afterwards during operation that could have been corrected with easy measures during construction. And afterwards, during operation, the costs like skyrocket, literally, because there is a structure already in place, there are cables going underground, we can just do it as it is required. So during the construction phase, thinking about that the solar farm is not going to live up to the commissioning time, but the solar farm is living up to 25 years or 40 years afterwards, depending on the PPA or depending on the feed-in tariff, we have to think about how to optimize the construction and the CapEx costs that we want to incur during construction in order to prevent much higher costs during the operational period of it. And then, of course, parts that relate to OPEX are the warranty claim management, performance reviews, engaging technical advisors into the analysis of the performance so that we can be sure that everything is going smoothly. And after all, along the time, there is going to be degradation, there is going to be loss of power, there are going to be issues with the inverters, with the modules, with the transformers, degradation of cables, and so on. So there is going to be a point when we will have to think about injecting some CapEx into it, tracing it along, understanding what technologies there are, for example, about ARC coating, anti-reflective coating, the PID solutions that we have already mentioned, or performance engineering that can be done onto site. All that will help us to reduce as much as possible the operational costs if we know what we have to look at and if we know what can be done to prevent or correct something on site. This is a very key slide for me because one of the major constraints that we have seen during operations has been the lack of communication or the misinformation between the EPC phase of the solar farm and also between the operational phase of it. There is always a big argument between both teams, EPC, realization, construction team. They want to finish as soon as possible, connect as soon as possible, commission as soon as possible, leave, off they go, and the site for them is kind of forgotten in many cases. And then the operations team is left with an asset of which they may know more or less, but sometimes they struggle to understand what's going on. Without much information, without that communication throughout the process. And from our perspective, it is very important that both the EPC team and the future O&M team are together working along the process, helping together into design, backfeeding each other of what they have seen as a problem afterwards or as a difficulty afterwards, and how can it be implemented, corrected, and improved in the EPC phase. Things like, for example, automation of the system, signaling, position and location of combiner boxes, inverters, design components. Afterwards in operation, you realize much more on how difficult it is to operate the asset, but during design, you only think of how to optimize the space, how to optimize the design. That's not matching always, and it is very important to have a good communication between both teams. And of course, this will help us to understand from the beginning what is the warranty claim process, because it is very clear normally for the EPC company but not so much for the O&M company in the first stages. Understand who has been involved, what subcontractors have been involved, who are the suppliers, key contacts in the suppliers list, and so on, so that everything is smooth and the transition between construction and operations is not disrupted, but to the eyes of the stakeholder himself, to the eyes of the owner, it is just smooth. It's as if nothing had happened in reality. For that, it is very important to be able to grab all that information in construction phase and design phase and to transfer it accurately to the O&M team. All the information that is relevant for the operations afterwards. So the information that they will need every day, day in, day out, the components that have been used, the problems that they have found during construction, the differences between what they thought it was going to be and what ultimately was constructed. Sorry. And ultimately, one of the key things that we need to do during operations is make good use of the monitoring portal, make good use of the monitoring tools. That gives us a lot of help in order to troubleshoot problems, in order to alleviate our manpower resources, in order to just focus more on preventive and predictive rather than corrective and reactive, which are much more less cost effective, much more difficult, preventing downtimes as much as possible, and so on. For this reason, one of the key things that a good O&M company and of course the EPC company has to look for is trying to get as much information as possible. Improve the monitoring system, choose good monitoring system suppliers that can give you what you need. If you want to have a better insight of your system, the first thing is that the monitoring system is adequate, is consistent, and gives you all the information that you need. If not, it's going to be very difficult to get it from the field staff or from the operator, the O&M company or the O&M subcontractor afterwards, because that's the basis, that's the heart, the main heart of the information that you will have. This helps us to drive our strategy and try to focus less on reactive, less on corrective, and tailor our strategies towards more preventive and predictive. This has been the main drive for O&M throughout the last years. We started with loads of reactive maintenance happening, not understanding how the operations were actually happening, why was the asset not performing as much as possible, not understanding what to correct or how to improve the operation, how to correct a failure, and so on. And we have stepped onto condition-based and predictive maintenance. Now we can understand, we have systems from other industries that have been implemented into PV and help us to understand why a transformer is having a better or a worse performance than the others, why there is gas generation in one transformer that it was not predicted or it was not expected. What can we do to improve it? And what can we do to prevent that from becoming a disruption to the system? And the other part that will help us to have better communications and ease the relationship between the owners and the O&M, and ultimately reduce a lot of cost because it gives us much more transparency, is having an asset management tool. Together with Patcon, we have been developing the BELECTRIC AMT tool. There are others in the market, but we are quite comfortable with this one, and we have been developing it to be bespoke to us. It is important to have a reporting and ticketing tool that helps both the asset owners and the operators to work smoothly. Whenever there is an alarm, we need it to be visible. We need it to be raised. If possible, implemented together with the monitoring portal so that it's automated. Anytime that an inverter hasn't performed as good, hasn't started, a combiner box has failed, or a transformer is down, to have automatically a ticket raised so that both the owners and the operators are understanding what's happening in lifetime, and then being able to tailor the future steps together. Be able to decide to what extent correct something, be able to trace down all the corrective and the preventative activities that have been done, be able to understand the spare parts that have been used, to be able to prognosticate, to understand in the future if increasing the levels of spare parts, if changing the amount of spare parts that we have, if adding spare parts that we didn't think to be failing, tailoring with all this big data information that we have had, knowing if we have to think about more preventative maintenance to happen every third, fourth, fifth, nth year, be able to implement that into the structure of the contract, of the scope of works, be able to know how to do it in the future without disrupting the system. It can mean doing works overnight, or it can mean doing something during high voltage shutdowns for transformer maintenance, for example, and then taking that as an opportunity to do other ancillary activities in order to prevent any fail down. And that being implemented into a ticketing system that is visible, so that instead of the asset owner having to raise his phone and saying, hey guys, what's going on? Why my system is not working? Being able to trace down, knowing when the failure happened, when the O&M team was called to go to site, who has been on site, what has been done, what has been inspected, and what are the resolution steps to be taken. This will give us much more confidence in the system and will improve much more the relationship between the asset owner and the operator. If this doesn't exist, the relationships are normally much more difficult, and the uncertainty and the costs because of miscommunications, problems of understanding, raise quite a lot. And as said, this can be implemented together with different tools, like, for example, accounting tools, purchasing tools, so that everything can be put all together. And this enables us, not only from the O&M perspective, but also from the asset management perspective, to understand it all, to be able to partake, to be able to be part of that live project that is the solar farm, and be able to interact to a certain degree with what's happening and tailor future decisions. Tailoring things such as, for example, how frequent the module cleaning has to happen, how frequent the landscaping has to happen. Sometimes we have found, for example, here in the UK, the landscaping plans that were implemented in the beginning were not good enough afterwards in the operations part. And there is a big kind of moral conflict between the owners and us, saying, okay, why don't we do it as it was foreseen? Why don't we do it as it was planned in the beginning? Why do you want to change it? Having more visibility into these topics gives us, also for the owners, gives them the tools they need to understand how to correct or how to improve their asset, basically their incomes, and how to implement strategies that will help them to get the most of the revenue. And yeah, basically repeating, so not to get into much, but just as a sum up, and now we can, of course, recap on a lot of questions. There are some of them that I see really interesting, but as a sum up, we want to be looking to the future. We want not to be just OPEX or operations 1.0 that we can define these operations up to now. We are into a second phase of the life of the projects. We now have to look forward to implementing better tools that will help us to reduce our costs, mainly in manpower, automate things, and improve the knowledge and understanding that we have on our systems. Of course, any further question that may not be answered in this Q&A session now, you have there my email, you will receive the slides, and feel free, of course, to contact us at any moment.
Thank you very much, Ruben, for your presentation, very insightful. And I see that, it's generated quite a few questions. So we have, I'll just pick a few of them so you can answer them. We have some time for these. So the first question is approximately what is the difference in costs during O&M for bifacial versus standard solar PV plants?
Mainly, one of the major differences is how to clean and what is going to be the expected yield of the bifacial afterwards during operation. That means that instead of having to clean just the normal surface of the module, you have a back sheet or a back face that you have to clean, and there have to be technologies in place for that project. So that's one of the main questions now in the market, how to do that, because in the backsheet normally you have also cables, the substructure, and so on. So there are much more difficulties physically and technologically there than in the normal phase of the module. So yeah, the costs are normally higher, but we have also to see how the technology develops and to what extent the module has to be cleaned at the back in terms of the degradation that is produced or the losses that are produced due to lack of energy received because of dust accumulated and so on.
Okay, thank you very much. And I have one question that is not one of the questions in the list, but it's mine. And what are the top, let's say the top 3 things that you could point out that you could look at the construction stage that will save you money later on during operation? So you mentioned a few things during your chat. You mentioned landscaping.
Yes.
You mentioned a few drainage things that that someone who is designing a system now and building it, that they can look at and design and build, so they save you money later on.
Well, that's one of them, landscaping and drainage, to improve the movement of equipment and machinery within the location of the equipment. Sometimes we have seen it quite a challenge, having combiner boxes in the middle of the rows, for example. From a design perspective, it makes a lot of sense because you save on cable, you save on losses on DC side, for example, but to what extent that is an improvement or that helps us afterwards to do troubleshooting, that's a bit difficult sometimes to determine, but it has been quite a challenge sometimes. And I would have to think, but yeah, again, the monitoring systems, to have them accurate, to have them that are giving us the relevant information, and especially during commissioning, make sure that everything is checked and confirmed, not having something commissioned theoretically, but afterwards finding out that it's not accurate and real.
Right, so you don't want to have any loose ends when it comes to your monitoring systems and find out that you thought that they were working, but they're feeding in information that is not accurate or is not correct.
Yeah.
Okay, good. Well, I thought that'd be helpful for someone who's actually thinking of designing and building their projects now. And let's pick some of the questions from the list, and there is quite a few questions by Amilcar. So Amilcar is asking, what is your view on the recommended real-time performance calculation algorithms integrated into SCADA of large PV plants?
It can be, normally we take them as an intuitive value for us to just have a rough idea. There are many other variables, and I think again it comes to the data collection and the SCADA system, the monitoring system, how it is done, how it is designed. Are you taking out, for example, shadows? Are you considering them in the calculation? And that ties in a lot as well with the operations contract that you have. What are the exclusions that you can have? What are the limitation factors that you can have? And if it is properly set up, it can be a very good help to just in a glance of sight have an understanding on briefly how the performance is. It's never accurate. There is always some brain that has to go behind the calculations, rerun them and rethink them. But definitely it can be just a good idea to have a first glance, a first visual understanding on how the system is. But again, it depends much more on the reliability of the data that you're getting.
Right, that does make a lot of sense. And there is a question here which I think it's quite basic, but I think it's fundamental really to understand, to get the most out of your systems. So what kind of data are you interested in getting and monitoring? So I suppose another way of actually phrasing this question is, out of all the things you could measure, I'm sure that these systems could be designed to measure thousands of things. What are the most relevant measures of performance? What's the most relevant data that you need to keep an eye
on? Normally, I don't know, just to check, do you mean for the performance calculation, or do you mean for the operation of the asset and troubleshooting?
The question, I think, refers to the data that you
collecting.
That you collect, I suppose, through the monitoring systems.
Yeah, I mean, in most of the cases, it's very important to have string monitoring as down as possible, as lowest level as possible, because it will save you from scanning throughout dozens of strings or pairs of strings. It helps you to accurately pinpoint where the failure is. And definitely, of course, key aspects as radiation, AC power, AC values like reactive and active energy, as much information as possible as well from the DNO, from the grid. And in the end, it later depends on your budgets and what is your expectation as well, what you can see. But definitely, one of the key important things is going as low as possible into details of the generation. So as the closest possible you can get to the string measurement, I would say is the best for both performance calculations and for troubleshooting and O&M operation.
Okay, so the more granular you can get, the better, essentially. Yeah. Right. Then there is an interesting question. I don't know if this is something you already do, but someone is asking whether you're using artificial intelligence in your maintenance.
Yes. And in fact, it's one of the biggest trends, as we said. That's why there is a lot of inclusion now of drone inspections, and there is a lot of analytics going on behind. For example, when you get thousands of pictures, of infrared pictures per megawatt, doing it manually has been the normal thing until lately. But there is a lot of artificial intelligence going on behind now to understand and differentiate what is a diode failure, a hotspot failure, multiple cells failure, a module failure, and so on. There is a first pre-filter going on so that most of the issues are generally classified, and you have specifically the picture that you need instead of having to run through thousands. There is a lot of insight going on as well regarding performance and internal calculations of softwares and platforms to understand better or worse performing strings, better or worse performing inverters. So things are now much more automated, and there are loads of algorithms going on behind. And of course, I mean, imagination is the limit only. There are a lot of possibilities with the data that can be done in terms of integrating it into monitoring portals that are fluid and that get all the information into one piece.
Right, that's very interesting, because that's kind of like what you have mentioned there is very practical applications of a technology that, well, that did sound like science fiction 5 years ago. So it's amazing to see that you're applying these type of new technologies. And you know, you mentioned, I saw your slides, and in your slides you mentioned digitalization as one of the trends. You've also mentioned that you don't want to keep on just doing the same things over and over again and improving necessarily incrementally, but you also want to, you know, see like the large improvements as well, using like new techniques. And I saw, I was wondering, what other areas could you digitalize to improve your operations and maintenance? Because what I can say is that there is what I call a lot of digitalization. So.
Yeah, I mean, there is from just giving the engineers digital tools like applications, web applications, or integrated apps that can give them tools just to go quickly doing their activities. There are loads of new tools and electrical testing features that we can get from different manufacturers that are being constantly developed and deployed. There is different assets. For example, I've been working together with a company that does monitoring system for transformers, and those have never been implemented into PV. There is a lot of areas where, for example, substation monitoring has been implemented that has never been used for PV because it has been considered like the basic system. It was never worth it, but gaining that insight gives us a certain degree of automatization to predict that something is going wrong before it happens. In the end, that is saving us time and money because you can tackle the issue before it becomes an incident in your solar farm.
And answering a question sent by Sanjay Gautam, could you comment on O&M on central versus string inverters?
I was speaking not long ago with one of my colleagues in Germany about that, and it's really interesting that for construction, even up to certain phases now, string inverters are competitive enough with central inverters. If nothing goes wrong, I would say central inverter is easier to operate in the long run. So for preventative maintenance, definitely a central inverter is a win-win solution because the maintenance is very limited compared to a string inverter. But if you start having issues, if you start having problems and you need to correct things, for a central inverter, you have to replace the whole unit if you need to replace it. Replacing a string inverter is very easy. It's a two-man job. It's just dismounting, reconnecting, you mount it again, and you have it live. So if the system is well designed and the system is well thought and everything has been okay in that phase of construction, central inverter probably is much cheaper to operate, not only from the OPEX part of manpower and inspections, but also in terms of spare parts, in terms of warranty management and so on. If you have a troublesome system or you can foresee, for example, shadows and so on, definitely a string inverter solution can be more applicable.
Okay, thank you very much. And there is also a question related to inverters here. Is do you have any preventive maintenance to predict the deterioration of inverter cooling? So yeah, any way you could prevent the deterioration of inverter cooling in utility scale systems?
In terms of inverters, we are seeing that they are quite difficult still to predict. There have been quite a few tests done by universities together with O&M companies. My colleagues in Italy, for example, were working in one project with a university there. And we are seeing that electronics in general are not easy to see the degradation into them. So once they fail, they have failed, but they don't give you so many clues normally. However, implementing, for example, for hotter environmental countries like, I don't know, Middle East or Australia, implementing into the program repetitive thermal imaging, for example, to the inverters can give you also some hints on hotspots. And if you do them correctly, you can see the trends. So you can start analyzing if something is slightly going different or deviating from the normal, and then trying to investigate it more in depth. So unfortunately, it's not so predictive sometimes, but with a proper program and with good training from the manufacturer, of course, knowing where to look into the inverter, it can be solved, and there can be lots of ways to improve the performance and avoid problems.
You know, and this ties in into another question that's here in the list, which is, do you believe that eventually you could replace routine scheduled maintenance with predictive maintenance?
To a large extent, probably, because in the end, you are, again, it all comes down to the granularity of the data you have, to the sensors that you have, but you can get to understand much better the system. And in our case, for example, we have systems that we can access remotely if they are properly configured within the SCADA, and we can remove alarms in the inverter, acknowledge them, and restart the inverter remotely without having someone there. So there are different technologies and there are different solutions already in the market that help us to reduce that frequency. And sometimes, I don't know, in many of the contracts, you have to go once a month. For example, here in Europe, in most of the cases, once a month just to visually check everything is all right. If you have confidence in the data that you are receiving, you are just, with a very easy strike, you are reducing in 8 visits the amount of visits that you have to pay to your site. So not to the 100%, I would say, at least not in our lifetime maybe, but there is going to be, and there is already, a big reduction on the manpower needs and on the preventative maintenance on site that can be done with the technology improvements and understandings of the system.
Thank you. That's interesting. My follow-up question was going to be, when were we going to be able to see this fully sort of like predictive system, but not within our lifetime. That makes sense.
I wouldn't say, yeah.
Yeah, it's hard to tell, but
Yeah.
Well, there is an interesting question here, which is about the amount of the stock of spare parts that you should keep. And the question asks, what do you think about the strategy of having spare parts on site? Sometimes a large amount, and especially of equipment such as pyranometers or step-up transformers. What are your thoughts on that?
There is also a consideration to be taken there, which is at what ambiental conditions this is going to happen. Our strategy, for example, we as BELECTRIC in the UK, we have a centralized warehouse for most of our projects, and we keep there in quite a controlled environment the spare parts that we are going to use. So we are avoiding humidity, temperature impacts, and so on, that can shorten a lot or even kill the parts, can shorten the lifetime or kill them. Items such as spare transformers, if you have a location close to the project or within the project, it can be useful, of course, to reduce times. Sometimes it's not only about whether storing them on site or not, it's probably also having good relationships with transporting companies, with, I don't know, high-up companies or lifting companies that can move easily the transformer from your location in the warehouse, in the central warehouse, to your place. Or if you can have the facilities on site, because it's a very large scale project, like the ones that we're having now, 300, 400, 500 megawatts, maybe you can already build in the facilities there that can be within a controlled environment. But it's definitely worth it having some parts, sometimes not only within the site, but maybe even with the technician if he is moving from site to site, because there are smaller sites, so that he's having them at hand, like fuses, MCBs, cables, connectors, and so on. Definitely having them close to site to reduce the downtime, it's a worth strategy. But there are some components that have to be kept in good ambiental conditions, and that is the risk, where to keep them so that you have a fast response time, definitely, without having to worry so much about in what conditions are you going to find the part when it comes to the solar farm and it's going to be replaced.
Okay, well, that makes a lot of sense. It sounds like scale has a lot to do with it.
Yes.
That if the larger the plant you have, then perhaps it's more worth it having facilities to keep spare parts.
Yeah, and definitely it's tied in with the OPEX costs. If you can build in a manned system there, or a building that can be constantly having a controlled temperature and humidity, of course, the larger the project is, the more cap you have there, the more options you have there to implement this kind of environment. If the project is smaller, always the margins are much smaller, and it's not feasible even to do it.
So, there's not one of the questions that came up, but it's a question that I've just thought of now. So in terms of scale, do you see a trend for larger projects now?
In general, yes. I think the EPC companies anywhere in the world, we are seeing that not only we see more interest, but we have more capabilities to plan a project that is of a larger scale, without compromising the quality and the results. So definitely there is a thrive onto that. And also because sometimes the markets call for it. Sometimes you have market restrictions that don't allow you or don't benefit you having larger scale projects. But many of the times, if we are going to market competition, so no PPA, no feed-in tariff conditions, or even PPA conditions, but to fight with the electricity on the grid, definitely you have to go for larger scales. And that is where the economy of scale plays a large part. Projects that couldn't be feasible being 100 megawatts can be feasible being 400 megawatts. So definitely there is a trend of these kind of projects in everywhere in the world, I would say.
And have you had the experience or the opportunity to maintain and operate a project that has a storage component to it?
Yes, we indeed have one in the UK, which is hybrid. So it is 3.5 megawatt peak solar farm. And then we integrated for test and a study that we were developing with National Grid here in the UK, another 1 megawatt hour battery storage. And that was for development, but it was basically to understand the integration between battery storage and a solar farm in normal operation conditions. And there is a lot of potential there, of course, about how you plan your coupling of the battery with the system, if DC coupling or AC coupling, if it is possible or feasible, what are the improvements in terms of losses or a reduction of losses. So there is a lot of market there, and there is a big opportunity there for the future, definitely.
And are there any special considerations in terms of the maintenance of a project of this kind, which has storage embedded in the PV plant?
Not necessarily. In the end, it's just one component more. If with accurate training and with good understanding on the battery operation itself, there is not much of a complexity. It's just, it changes, of course, the scope of services, the scope of checks, and the training that you need to have for your skilled manpower. But in terms of increased frequencies of maintenance, I wouldn't say so. In fact, the maintenance scopes that we are having for battery projects are reduced compared to the PV project. So it doesn't increase, rather it would tend to decrease it in terms of the whole project. And if it is well designed and well built, definitely there is no critical path in that way.
Well, that sounds like good news, because less complexity in these cases is good.
Yep.
In general. Right. I mean, we do have a few questions, but I think that if it's okay, perhaps we'll take those via email, if you don't mind.
Definitely.
I'd like to thank all of our viewers for being here and with us for almost like the full hour and asking very interesting questions. And thank you, Ruben, for presenting. It's been a very insightful presentation. So we have a number of webinars on the topic of operations and maintenance, and we have one coming up on cleaning technologies. And if you go to the chat box, you can see the link there. And if you're interested in this type of topic, I recommend that you join this webinar as well. Would you like to say a few parting words to the audience, Ruben?
Well, definitely all the best in this market. There are lots of opportunities and great emerging markets out there, and the already consolidated markets like Europe or the US, they are still thriving. So just keep on pushing, and definitely think of the future as not only in terms of OPEX and the topic of today. Think very well and coordinate with your O&M teams, because it's going to be much more beneficial. And let's work all together to bring this to a reality, to have maybe not 100% of renewable energy, but as much as possible in the short-term future, definitely.
That's a good goal to aim for. So close to 100% renewables.
Yes,
Let's
as
see.
soon as possible.
As soon as possible. Well, thank you very much. Have a good day. Thank you to everyone in the audience, and thank you, Ruben. And see you all soon here at our webinars.
Bye.
Bye.